Good afternoon, everyone. My name is Ben. I come from China. I'm now the technical marketing of this company, NOVOSENSE Microelectronics. And today, my topic is advancing eMobility with magnetic current sensors. So I have three topics today. The first one, current sensing in eMobility. The second one is NOVOSENSE magnetic current sensor solutions. And the third one is technical experience or expertise of NOVOSENSE in sensor development. Okay. Before we go to the main topics, I would like to simply introduce the company, NOVOSENSE. And it was founded in 2013. So up to now, there are about 800 employees. In the year 2022, and this company was successfully listed in Shanghai, in China. And there are three famous levels of this company. The first one is that we are provided for all category analog and mixed signal chips. And we are also a leading chip supplier for automotive devices. And in the year of 2023, more than 30% of the business comes from automotive. And we are also a leading provider for digital isolators and also sensor products. They are mainly design centers and the sales office in China. And as for the overseas branches, and we have a sales office in Germany, and a sales office in the US, and in Japan, and in South Korea. So it's very easy for you to find some local sales members and FAA members from Germany and have a fast discussion on our products. In general, NOVOSENSE is a system solution provider. So centered around the microprocessor, and we can provide many kinds of products, including the sensor products like the temperature sensor and humidity sensor, and the magnetic sensor, and also pressure sensor, and this kind of stuff. And for the interfaces, and we have a CAN interface and a link interface, and also digital isolator. And for the power management ICs, and we have some PMIC, and we have isolated power supply. And we also have a pass protector. And for the driver ICs, and we have many kinds of products like the isolated driver and non-isolated driver, and also the high side switch and low side switch. And for the isolated sensing products, and we have some isolated amplifiers for the voltage sensing and the current sensing. And the last one, even for the power devices, and we have some SiC diodes and also SiC MOSFET. We have so many kinds of products. So today we only focus on the current sensor here. Actually, the growing carbon emissions and the greenhouse gases are encouraging the environmental body, the manufacturers and also the government bodies to promote the solutions of eMobility. And the car makers in China especially, and they are moving at full speed towards eMobility, like the EV and the HEV. So here you see the charts of the sales volume in China. In the year 2022, the sales volume of NEV is around 6.2 million. But in 2023, it's about 8.3 million, with a growth of more than 30%. Regarding the export volume, and in the year of 2022, China shipped more than 600 kilo EV cars to abroad. But in the year 2023, this volume is almost double. Yeah. So the rapid growing of the eMobility is reshaping the automotive industry of China, even the world. And eMobility also brought some expansion of the related infrastructure, like the grid and also the chargers and this kind of facility. And some environmental forces are leading the demand for power this kind of eMobility system with the renewable generated power supply. For example, the solar energy or the wind energy. So here is an example of the solar energy. So the current flows from the PV to the inverter and to the meter, then to the grid, then to the charger, and finally to the EV. So there are many places for current sensors. like the current sensor for PV, current sensor for inverter, current sensor for meter, and the current sensor for the chargers, and even multi-points for the current sensors of EV. NOVOSENSE have two kinds of current sensors. The first kind is we call integrated current sensor, and the second type is a linear current sensor. And for the integrated current sensor, we have different kinds of packages, from the smaller one to the biggest one. So different packages, they have different the conductor resistance and the different package size. So for example, this one have 1.2 million milliohms conductor resistance, and this one have only 0.1 milliohms resistance. And the different packages, they have different capability of continuous current. For example, this one can only support the 30 ampere continuous current, but this one, it can support up to 200 ampere continuous current. And the different dimensions also determines the different isolation capability. The smallest one can support only 600 volts, the basic isolation, but for the bigger ones, the capability is even up to more than 1600 volts. Under each package, we can see many part numbers. Some parts are designed with the geometric output, and others with fixed output, and combined with different supply voltage, like 3.3 volts or 5 volts. So we have a lot of part numbers in mass production, around 200 part numbers in mass production, and supporting the customers from automotive, from industry, and from consumer. On the left side, we see a simple structure diagram of the integrated current sensor. So the left side is we call primary side, and the right side is the secondary side. Between the primary side and secondary side, there is insulation layer. That's why we can achieve the high voltage for isolation. And the current flows into the conductor inside of the body of the sensor, and generates the magnetic field on the left side and on the right side of the conductor. And we use Hall sensors on both sides and sense the magnetic field, and then convert them to the desired voltages, like 0.5 volt to 4.5 volt. Okay. Compared with different solutions like the shunt resistor and the amplifier, and also the current sensing module, this kind of solution is quite small in size. It's compared to size, and also it's very easy for design. No need for the shunt resistor, and no need for the isolated power supply. And what is most important is that this kind of solution is with very good cost performance. Okay. As for the linear current sensor, and we also have different kinds of solutions, like the core-based solution and also the core-less solution. For the core-based solution, this kind of sensors normally works together with the magnetic core and sense current up to 1,000 amperes. And this is the first generation. The typical performance is plus minus 2% sensitivity drift over temperature range, and plus minus 10 millivolts offset drift over temperature range. But for the new generation, it's relatively better. The drift is only 1%, and 5 millivolts offset drift over temperature range. And temperature range from minus 40 degrees to 150 degrees. And this part, the surface mount device, and it can support both the core-based solution and also the core-less solution. So the core-less solution doesn't need the core. It can provide better cost performance. Okay, in NEV, so there are quite a lot of high voltage systems, like the BMS and the PDU, OBC, and PDC, and this kind of stuff. So NOVOSENSE current sensors, we have a lot of successful stories here. Like the inverter, we have the linear Hall current sensors, and for BMS, we also recommend the linear Hall current sensors. But for other systems, like the OBC, DC-DC, and the charging pile, and also charger, and the OBC and the PTC, we have a lot of products in mass production and the customer side for isolated current sensing. Okay, let's look into the block diagram of the OBC and DC-DC. So there are many places need the current sensor. So the left one is the PFC current sensing. So the current level is typically below 65 ampere, and the accuracy requirements is only 2%. So regarding the isolation, because the sensor must be galvanic isolated from the line voltage. So for this application, and we have so many products to recommend. And for the inductor current sensing of the IOC, and this place need a really high bandwidth because the frequency of the current may be much larger, up to several hundreds of kilohertz. So we have some high bandwidth current sensor. This one have a 1 megahertz bandwidth. And the next one is for the charging current sensing of the high voltage battery. And this place, because the battery is 400 volts or 800 volts typically, so the galvanic isolation is must. And the typical current of this current is below 35 amperes. So we have this kind of recommendations here. And the last one is for the low voltage battery, because the voltage here is only 12 volts. You don't need the isolation, but the current is much larger, up to 300 amperes. And for this application, and we have some small resistive current sensor and also the colloid solution. Another critical system in the EV is the traction inverter, and the current sensors are needed for the phase current sensing and also the bus current sensing. So typically, the accuracy requirements of these current sensors is only 2%. We have a lot of products in mass production, and due to the high voltage of the battery, so the isolation is also needed. So we have some core-based solution to recommend. This kind of sensors are typically built to some modules for the current sensor for the traction motor. Except the automotive applications, we also have a lot of industry and consumer applications, like the solar inverter and the motor controller and the medical devices, and also the UPS power and the power supply, and even the current sensor modules. Let's take this one, for example, the solar inverter. Here is the system of the solar systems, system diagrams, and there are many places for the current sensing, like the PV current sensing, and the eMobility current sensing, and the current sensing for the battery, for the energy storage systems, and also the current sensing for the AC current. So for the PV current sensing, so typically the current is 16 amperes and maximum at 20 amperes. And there is high voltage of this PV string, so isolation is also required for this application. And we have a lot of products in mass production for this area. And the second one is for the eMobility current sensing. Typically, the current is times larger than this one. It's 1 string or 2 string or even up to 6 string. So the current may be 20 amperes or 40 amperes or even 120 amperes of this position. So we have some products to recommend for this place. And for the battery current sensing, and depends on the voltage level and the energy level of the system, they may need the isolation and they may need non-isolation. So for this position, we do have some successful stories of this part in some China, some suppliers of solar systems. And for the AC current sensing, it is critical that the current sensor need a very low DCI, very small offset error. So for this position, according to the regulations of the government, we need the offset error below 1.5% of the current. So we also have some special flavor to support this application. Okay. The history of the sensors at NOVOSENSE. And since we founded this company and we started business from sensor products, and in 2014, and we released the first 3-axis accelerometer ASIC. And in 2015, and we released the first pressure sensors. And in 2016, and we released the first automotive device. And in 2018, and we started mass production of automotive qualified pressure sensors and also temperature sensors. And in year of 2021, we released the first Hall effective current sensor. And from then on, we have a rapid growth of the Hall effective sensors. And from 2021 to 2024, we have released sensors like the angle sensor and the position sensor and the switches and so on. And in year of 2024, NOVOSENSE, this company became a member of the AEC committee. Okay. After years of emerging in the sensor industry, and we have accumulated a lot of expertise and experience of sensor development. We have mastered the technology of design MEMS on wafers, on bulk wafers, and also on SOI wafers. And we released the products like the relative pressure sensor and also absolute pressure sensor. And in year, we also mastered the technology of humidity sensor, and we have some products in mass production to sense the temperature and humidity at the same time. As for the magnetic sensor, and we have a lot of technologies. Here we released some products like the current sensor, position sensor, and angle sensor, and switch and latch from the planar Hall technology. And we are also working on the vertical Hall technology, and it will be ready at the end of this year. And we planned some products like 3D angle sensors and also the 3D switches. And besides the Hall technology, we are also working on the MR technology, like the AMR technology and TMR technology. Okay. Besides the sensor technology, and we also have a lot of expertise on the package design, including the exterior and also the interior. So for the outer line design, we have some customized MEMS package, and we also have the package with the thermal dissipation pad on the top of the package. And we also have some wafer level CSP, very compact package. And we also have some plank design of the package. Regarding the interior design, we have some different types of bonding wires, and we also have some composite materials to achieve the high voltage isolation. And we also have some products with different isolation lines inside of the IC. For example, this one, it has 2 lines of isolation, and also integrate a PCB transformer inside of the package. And for the last one, it's a very complicated package, and we have 8 dies inside of one IC. 4 dies on the front side of the lead frame, and another 4 dies on the back side of the lead frame. It's a very complicated product. It's for some function safety required systems. We can provide the redundancy. Okay, so welcome to our booth at the booth number 636 and in the hall 9. Thank you.